Are you ready for this? Like, get this. A cosmic mystery. It's been puzzling scientists for, like, over 2 decades.
Yeah.
We're talking about a planet that just totally breaks the rules of how planets form, especially in the early universe.
Right.
Like, how early are we talking?
Very early.
Okay, well, let's get into it. So it's a story of unexpected discoveries in cutting-edge telescopes. And these theories, right, that are pushing the boundaries of what we thought we knew about the cosmos.
It really challenges some pretty long-held assumptions about planet formation.
Like what?
Well, for years, the prevailing theory was that planets needed heavier elements.
Right.
Things like carbon, iron, even oxygen
Okay.
to, clump together
Right.
and form those initial planetary seeds.
It's kind of like, right, those heavier elements were,
Yeah.
like the essential ingredients in the cosmic recipe for planet formation. And that makes sense, right? Especially when we think about it, right? The early universe was so different from what we see today.
Exactly. Heavier elements are forged in the hearts of stars,
Okay.
specifically as they die.
Okay, yeah.
So in the early universe, before generations of stars had lived and died,
Right.
those elements would have been much rarer.
So how on Earth, or rather how in space,
Yeah.
did a giant planet form like billions of years ago?
Right.
When the universe was still basically like a baby.
That's the million-dollar question.
Yeah.
So back in 2003, the Hubble Space Telescope
Oh, Hubble, okay.
discovered a massive planet orbiting
Okay.
an ancient star
Okay.
in a globular cluster
Right.
called M4.
Oh, okay.
Now, globular clusters, these are
Okay.
tightly packed groups of stars,
Right.
some of the oldest in the universe.
Wow.
And this particular planet is estimated to be around 13 billion years old,
Oh.
meaning it formed when the universe was just a fraction of its current age.
Okay, wait. So we've got a planet that's almost as old as the universe itself.
Right.
It's just hanging out in a place where it shouldn't even exist.
Exactly.
So what does that tell us about how planets, like, might actually form?
It suggests there might be more than one way to bake
Okay.
a cosmic cake.
I like that. Okay.
And to unravel this mystery,
Okay.
we need to go beyond our own galaxy
Oh.
to a fascinating star-forming region called NGC 346.
NGC 346.
This region
Okay.
is located in the Small Magellanic Cloud,
Oh, wow. Okay.
which is a dwarf galaxy that orbits our Milky Way.
Gotcha. Okay.
It has conditions similar to those found in the early universe.
So NGC 346, it's like a time machine
Yeah.
that lets us, peek back
Yeah.
into the universe's baby pictures
Yeah.
and see how planets might have formed way back then.
Precisely.
Okay, cool.
It gives us a unique laboratory to study planet formation
Okay.
under conditions that mimic the early universe.
Right. So like a little test kitchen. Yeah.
For planets, that's cool.
And when Hubble first observed
Yeah?
NGC 346,
Yeah.
it picked up something quite intriguing.
Oh, I love a good astronomical cliffhanger. What did Hubble see?
Hubble detected signs of planet-forming disks
Okay.
around young stars in NGC 346.
Okay.
But
Yeah.
these disks were behaving in a way that defied expectations.
Oh, boy.
They were lasting much longer
Okay.
than we thought possible.
Wow.
Like 10 times longer.
Wow.
Even with the limited amount of heavier elements.
Really?
It was a hint
Yeah.
that maybe, just maybe,
Yeah.
those heavier elements
Yeah.
weren't as crucial as we once believed.
Okay, so now I'm really curious. How do we go from a few, intriguing hints to actual evidence that, challenges this understanding of planet formation that we thought we had?
Yeah.
And, what role does the James Webb Telescope play in all of this?
Yeah.
This feels like we're about to enter.
The next chapter of this cosmic mystery novel.
You hit the nail on the head.
Yeah.
Hubble gave us tantalizing clues,
Okay.
but it needed backup.
Right?
It's like trying to piece together a puzzle
Right.
with only a few pieces.
Yeah.
Enter the James Webb Telescope,
Ooh.
our new all-star player
Okay.
in the world of astronomy.
Right.
This telescope, with its incredible sensitivity
Okay.
and advanced instruments,
Yes.
was able to zoom in on NGC 346
Right.
and provide much clearer observations.
So basically, James Webb is like the high-powered magnifying glass we needed
Yeah,
to get a good look at those planet-forming disks.
exactly.
So what did it see? I mean, did James Webb confirm what Hubble kind of hinted at?
It did, yeah.
Okay.
In 2023, James Webb used its near-infrared spectrograph
Okay.
and mid-infrared instrument to observe NGC 346.
Right.
And the data was, like, crystal clear. So those planet-forming disks, they were indeed lasting much longer than expected, even in an environment with fewer heavy elements.
Really?
Yeah, it was a huge moment for astronomers.
I bet.
Because it really solidified this idea that our current understanding of planet formation might be too limited.
So heavier elements might not be, like, the be-all and end-all of planet formation.
They might not be.
Okay, so if that's the case, then what's keeping those disks from, dissipating so quickly?
Yeah. What are the scientists saying?
That's where the theoretical fun begins.
Ooh, okay.
There are two main theories being explored.
Okay.
Both of which offer really interesting explanations.
All right, lay them on me. What's the first theory?
So the first theory kind of delves into this relationship between a young star and its surrounding disk.
Right.
We know that stars emit stellar winds, which are essentially streams of charged particles.
Okay.
Now, heavier elements are thought to play a role in how these winds behave.
When there are more heavy elements present, those stellar winds, they pack a punch, gaining more momentum and dispersing the gas and dust in the disk more effectively.
Well, if there are fewer heavy elements, then those stellar winds would be weaker.
Exactly. Imagine it like this. With fewer heavy elements, the stellar winds become more like a gentle breeze. Instead of a powerful gust.
Gotcha.
They don't have that same force to push away the material in the disk, allowing it to hang around for much longer.
Interesting. So it's like the lack of heavy elements is actually like creating a more stable environment for planets to form. But what about the second theory?
Right.
What's the alternative explanation?
The second theory focuses on the size of the initial gas cloud that collapses to form a star and its surrounding disk.
Right.
It suggests that in environments like NGC 346, where heavier elements are less abundant, these initial gas clouds might be significantly larger than those found in other regions of the universe.
So if you start with a bigger cloud, you end up with a bigger disk.
Yeah.
It seems pretty straightforward.
It does, but the implications are profound.
In what way?
A larger initial gas cloud means there's more material available to form both the star and its disk.
Yeah.
This could result in a more massive and longer-lasting disk.
Gotcha.
Even if the proportion of heavy elements is relatively low.
Okay, I see.
Yeah.
It's not just about, like, the types of elements present, but also about the sheer quantity of material you're working with.
Exactly.
More material means more time for the disk to, stick around and for planets to potentially form within it.
That's right.
Okay.
Both theories are still under investigation.
Right.
And it's possible that both mechanisms, or even combination of the two, are at play.
It's fascinating how one seemingly impossible planet can lead to such a, paradigm shift in our understanding of the universe. We went from assuming that heavier elements were absolutely essential to now considering alternative pathways for planet formation. And it all starts with a simple question. How is this even possible?
Exactly. It highlights the beauty of scientific inquiry.
Yeah.
We observe something unexpected, we question our assumptions, and we explore new possibilities.
And sometimes those new possibilities lead us to, rethink some of the biggest questions about our place in the universe.
Absolutely.
Speaking of big questions, we've been talking about planets forming, earlier than expected.
Right.
So if planets can form earlier, could life also emerge earlier than we thought?
It's a great question.
Yeah. And if so, what does that tell us about the potential for life elsewhere in the universe?
Right.
It feels like we've stumbled onto something truly profound here.
It's a question that really captures the imagination.
Yeah.
If we consider that planets could be forming earlier and under more diverse conditions than we initially thought.
Right.
It opens up a whole new realm of possibilities for when and where life might arise in the universe.
It's like we've expanded the cosmic playing field for life.
Yeah.
And if life had more time to, get started, billions of years even, what does that mean for the types of life that could be out there?
It's mind-boggling, isn't it?
Yeah.
I mean, we tend to think of life as we know it.
Right.
carbon-based, dependent on water. But like, what if those are just the starting points? Imagine the diversity of life. That could evolve over billions of years. Under completely different conditions.
It's a humbling thought, right? To realize how much we still don't know. We've spent centuries studying life on Earth. But it might just be one tiny example in a vast cosmic library of life forms.
And that's what makes this discovery so exciting. It challenges us to broaden our perspectives. And consider possibilities that we might have dismissed before.
It reminds me of that feeling you get when you look up at the night sky and realize just how vast and mysterious the universe truly is.
Exactly. It's a reminder that there's so much more out there waiting to be discovered. Who knows what other impossible planets or like mind-blowing phenomena are just waiting to be found.
Well, I, for one, can't wait to see what the future holds for astronomy and, our understanding of the universe. In the meantime, I think we've given our listener a lot to think about today.
Definitely.
We started with a single planet that seemed to break all the rules. And now we're like contemplating the vast potential for life across the cosmos.
Yeah, it's pretty amazing.
It's a pretty amazing journey for a short deep dive, wouldn't you say?
Absolutely. We've gone from the specifics of planet formation to the grand implications for life in the universe. And we've done it by, exploring real scientific data and engaging with current theories.
And that's what I love about these deep dives, right? It's all about taking, complex information and making it accessible and exciting. It's about sparking curiosity and giving our listeners a taste of, the incredible discoveries happening in science every single day.
So to our listener out there, keep looking up at the stars. Keep asking questions. And never stop being curious about the universe and our place within it.
Beautifully said. And remember, even when something seems impossible, the universe always has a way of surprising us. We'll see you on our next deep dive.